Okay, today we'll speak about RF imaging. We are already aware that CMOS cameras are there. They are used to capture image based on IR principle, infrared. But today we'll talk different, that is electromagnetic waves based imaging. In electromagnetic waves, what we do, we transmit or generate a signal at terahertz frequency. Then these terahertz frequency signals are being received by detector, and the detector will generate pixel, and these pixels in gray RBG will be collected by processor, and then the image will be found and processed further. This is basic principle of EM wave based imaging. What is different here is that we basically replace this detector with RF absorbers at terahertz frequency. The basic fundamental of RF absorber is that it receives EM wave at particular frequency and convert this into corresponding voltage. These voltages will be termed as corresponding pixels based on intensity, and these pixels will be rearranged to generate the image. That is basic principle of absorber based imaging. Now, the physics of imaging is either reflectance based, transmittance based, or absorbance based. With all these three methods, we can generate image based on received terahertz signal, that is terahertz received wireless signal. Now, based on these three methods, we compute refractive index and absorption coefficient. Depending on the absorbance coefficient and refractive index, we will be able to correlate with pixels intensity, and these pixels intensity in correlation with some matrix format will be able to develop image. Now, where we can use them? The RF based imaging is more useful for biomedical applications. So far, we have been developing these images using X-rays based on EM wave, but these X-rays are creating ionizing effect into human tissue, which is dangerous. But being non-ionizing wave at terahertz and giving us the same even better quality of image is one of the crucial research in EM fields at terahertz frequency. But to design this absorption, to design these type of terahertz absorber, we need to find out the following parameters. One is total impedance, that is ZT, and ZT is R plus JX. It must be equal to free space impedance, that is 377 ohm. The absorber must be polarization insensitive. What it means that it must receive the wave either it is at TM polarized, TE polarized, TM polarized, and not only at fundamental mode but at higher order mode. What does higher order mode means? We'll take one separate lecture on generation of fundamental mode and higher order modes. But basically, I want to convey here that TE MNP, TM MNP, these MNPs are indices. Based on the value of MNPs, we will be able to describe fundamental or higher order mode. Coming back, that it must be polarization insensitive. Then for absorption, we need to compute the imaginary part of permeability and imaginary part of permittivity. So in total, we can say that the loss occurred due to imaginary part is the main parameter in case we develop absorber. Phase delay or group velocity is another parameter. Then the material which we want to from which we want to design this absorber is also important parameter. Reason being, if we take FR4, that is valid only at microwave frequency. For terahertz frequency, we need to go for TiO2, SiO2, and there are many more materials available, graphene, graphite at terahertz frequency. We will talk about them in later part. So detector, when we say absorber, it is a detector. We want that the bandwidth of this absorber or detector must be huge. So again, the spectral or frequency based the terahertz or any frequency absorber will be catered for. Shape of the absorber is also a parameter. Reason being, if we develop conical shape absorber, definitely the incidence angle will be wider for conical shape. But we are not restricted to only conical shape absorber. We can design rectangular, we can design cylindrical, and many other shapes are there. So shape is also important parameter as far as the terahertz absorber is concerned. Then getting the image will be based on spectral signature. We will when we talk about higher order modes, that time we can talk about what is spectral signature, because the pixels pattern and intensity, these are the two parameters where we will discuss about the spectral signature. Because gray, RBG, these are the pixels category, and the image quality will be based on the intensity of these pixels. All four: gray, RBG, where RBG is red, blue, and green. Now, after we design these absorbers at any frequency or depending on a spectral relative, we need to apply these absorbers for a particular application. The application can be the we can use them to convert input incidence EM wave into voltage. Then we can use them for imaging. Then we can use them for retina. We can use them for electromagnetic compatibility, and the major application in military, we can use these absorbers for stealth. This is all about introduction of these absorbers and uses of absorber as detector in imaging. Thank you.